Hello, everybody. My name is Fuli Liu from Open University of China. I'm very pleased to join this workshop on seaweed strain selection and breeding regulations. Today, I will share with you China's experience in seaweed aquaculture and breeding, with a special focus on selective breeding and its regulatory framework. Firstly, let me begin with a quick overview. China is the world's largest producer of farmed seaweeds, accounting for nearly 50% of global production by fresh weight. More than 10 seaweed species are commercially cultivated in China. The top species by volume is Saccharina japonica. It was known before as Laminaria japonica, which makes up over 60% of total production. Gracilaria follows at about 20%, and then the Wakame and Nori. As we all know, improved varieties or cultivars are a key driver of this industry's sustainable development. China has prioritized seaweed breeding research since the 1960s. Over the decades, we have developed several breeding methods. For example, the selective breeding, hybridization, mutation breeding, and more recently, molecular breeding. This method shows difference in terms of efficiency and popularity in China. Today, I will focus on selective breeding because it remains the most widely used and successful approach in China. The theoretical foundation for selective breeding in kelp was proposed as early as in 1960s by Professor Fang Zongxi, a pioneer in Chinese seaweed research. The idea is very simple. As we all know, the early farmed seaweeds came from wild populations with high genetic diversity. By repeat inbreeding, either safely or within population crossing, we can progressively homogenize the genotypes. Then, through artificial directional selection, we enriched the derived traits such as high yield or heat tolerance. Technically, this requires at least 5 consecutive generations of selection to achieve genetic stability and trait uniformity. That is the standard we follow in China. So, what has China achieved? To date, China has officially approved 24 nationally certified new seaweed varieties. Among them, 15 were developed through selective breeding. Let me give you an example from our own research. My team compared the morphological traits of kelp from the 1980s to the 2020s, including blade length, blade width, and fresh weight per plant. We can saw from this picture. The picture shows that the very significant improvement over the 4 decades. Selective breeding play a major role in this process. This picture shows one of the varieties bred in China. It's named Huangguang #1. Now let me move to the regulatory side. In China, the definition of a cultivar or variety is quite clear. It refers to a genetic population developed through artificial breeding that has 3 essential characteristics. First is the distinctness. It must be distinguishable from the other existing varieties. Second, uniformity. Low variation in key economic traits, indicating genetic homozygosity. The last one is the stability. The key trait remains consistent across the different generations and the different environments. As for certification, we have an official body called the National Commission for Aquatic Original and Improved Varieties, or NCAOV. It's under the Ministry of Agriculture and Rural Affairs of China. Most of its members in this commission are scientists in aquatic breeding field, but it also includes representatives from government and the seaweed industry. The commission holds an evaluation meeting once a year. Breeders submit their application materials of the cultivars. The members of this commission review and evaluate them, and then a final decision is made through voting. Of course, selective breeding has limitations. First, the breeding cycle is long, at least 5 years. Second, selection efficiency is low. Efficiency is very low because the traits must be evaluated at the sea, which requires high cost and labor. Finally, we found that the long term of selective breeding will reduce the population genetic diversity to a certain degree. And so what is the future? We are now developed molecular tools. One direction is marker-assisted selection, mainly for quantitative traits like coding content. We have identified some linked markers, and now we are testing the efficiency of these markers in the assisted selection. Another direction is genomic selection. We have used the GWAS method. We have preliminarily identified the markers associated with heat tolerance in carp. We are now developing high density SNAP markers through genome resequencing and building genomic prediction models for breeding value. And about the first question, my answer is as follows. China's experience shows that heat-tolerant varieties can be developed. For example, carp cultivate in southern China, for example, in Fujian province, is generally more heat tolerant than northern strains in China. So we can cross the southern heat tolerant strains with the northern high yield strains. Then we can obtain the new cultivar with high yield as well as high heat tolerant. But how do we avoid losing genetic diversity? I think we need to develop the genome-side SNP markers and conduct GWAS to identify loci specifically associated with heat tolerance. Then we ensure that the selection only homogenized those target loci, while preserving the diversity as the neutral or unrelated loci. This is the key, I think. About the second question, I suggest 3 actions. First, we should strengthen the technique guidelines, strictly enforce the requirement for distinctness, uniformity, and stability, and mandate at least 5 generations of selection. Second, we should integrate new technology into the traditional selection breeding program. For example, the marker-assisted selection and genomic selection can reduce the cost and labor and improve the accuracy of selecting target genotypes. Third, we should strengthen the management of approved varieties. For example, we should to define and restrict the geographic regions where each varieties can be farmed. Then, use this method, we can prevent the mixing of different varieties to avoid unintended hybridization and monitor the variety performance over time. If the performance degrade, we can stop use this variety. To conclude, China has a long history and a rich experience in seaweed selective breeding. We have a functioning regulatory system, and we are actively exploring new molecular tools to make breeding faster and smarter. I hope our experience can be useful to the international community. Thank you very much for your attention. Thank you. That's all.